Hi, I'm Terry Klinker. We're going to continue our discussion of decision analysis. We're going to continue with our discussion of expected monetary value, and this video is going to show you how to do a graphic solution. Now, one of the things you're going to have a problem with in this section and a couple other sections that we do in this class is you've forgotten how to do 7th grade algebra. You've forgotten how to draw straight lines. Once you're done chuckling at yourself, or chuckling at me on the other hand, about 30% of you fall in this boat. You're going to forget how to graph a straight line, and you're going to struggle because you can't graph it. It takes a little bit of practice, so once you're done laughing at me for this, I'm going to show you how to do it. So we've got our lines already. We went through and we found out the expected monetary value of small was $8 million, the most we can get if it's weak, minus the probability that we have strong demand. The expected monetary value of medium is $5 million plus 9 times the probability that we have strong demand. The expected monetary value of large is minus $9 million plus 29 times the probability that we have strong demand. Small demand has a very small slope, and it's a negative slope. Medium has a much larger slope of plus 9, and it's positive. Large has an extremely large slope, and it is positive. Why does that make sense? Well, we're measuring it against the probability that we have strong demand. As we have stronger demand, small loses money, therefore the negative sign, but it doesn't lose much. It only loses $1 million. Therefore, the slope is negative, but a small negative number. As we go from weak to strong, as the probability of strong increases, we go from 5 million to 14 million. So it's a positive amount of money, and it's a significant amount. It's much bigger than this 1 million we might lose here. We could gain 9. Here it starts low. As it goes, as we get more and more positive, we could go up $29 million. So it has a very large slope. How do we plot this? Well, we plot it using two x-axes. So let's start out with two x-axes. Two y-axes, two vertical axes. The axes are expected monetary value increasing this way. The horizontal axis is P, the probability of strong demand. P goes from 0 to 1. It goes from no chance of strong demand to 100% chance of strong demand. Expected monetary value, the lowest number we have, go back to your maxi-min decision earlier, the least we can have is minus 9, the most we can have is 20. So the y-axis is going to go basically from a minus 9 million to a plus 20 million. This is where the probability of strong demand is 0. We do not have any likelihood of strong demand. If we don't have strong demand, what do we have? If P is 0, if there is no chance of strong demand, we have weak demand, right? 1 minus P, 100% minus 0, means we have a 100% chance of weak demand. Therefore, this axis, this vertical axis, is weak demand. At 100%, we have strong demand. The chance of weak demand, if P is 100, 1 minus 1 is 0. So this axis is strong demand. What it really means is, whatever the number for weak is, that's going to be plotted here. Whatever the number for strong is going to be plotted here. Since we have a slope here, it's a linear function, we can just draw a straight line between them. That might confuse you. So let me do it another way. Here is my equation of a line. Small. My axis, my intercept is at $8 million. This is the axis we intersect with. It's where my value of x, my horizontal axis is 0. So for small, it intersects at $8 million. On the other axis, where we have strong demand, it's $7 million. So over here, it's going to cross at $7 million. It's a linear function, so it's a straight line. That gives me the value for any value of P, any market evaluation of what the probability of strong demand is. This gives me the value for any number of P of what I should expect for an investment in small condos. If P is 0, if I have weak demand, my intercept for medium is 5, so I would be over here at $5 million. If it's 100%, it would be at 14 million. 14 million. It's a straight line between the two. That gives me the value for an investment in medium for every value of P between 0% and 100%, every probability of strong demand. My y-intercept for large is -9. If I have no chance, if P is 0, I have weak, I'm at -9. It goes up 29 units for every unit of P, so it goes up to 20 million on this side. Again, it's a linear function. And there we are. We now have our graph that tells us what the values are for each one. Now, take a look at this. What do we have? It says that if P is 0, I could have a -9 million, 5 million, or 8 million. Well, that's exactly what this says. If P is 1, 100% chance of strong demand, I could have 7 million, 14, or 20. 7, 14, or 20. We also have something that we would refer to as a curve that's called expected monetary value max. The maximum expected monetary value would be this upper curve. We're trying to maximize investment. So it would be this curve right here that shows us for every value of P, what's the most we can get. It also kind of defines something for us. If I drop these down, if I drop down to this intersection, drop down from this intersection, at this value of P, from 0 to this value of P, the best option for me is small condos. If P is between this number and this number, I would prefer to invest in medium condos. And if P is bigger than this, as P gets from this closer to 100% probability of strong demand, I would prefer to invest in large condos. All right? That's exactly what this says. So what would we want to know here? Well, we'd want to know what the value of P is here. Well, that goes back to what we said earlier. What is this right here? This is an intersection. What is it really? It's where the expected monetary value of medium and small are the same. That's our definition of what? Indifference point. If we find the indifference point between small and medium, we'll find that value of P. So it's going to be where the expected monetary value of small equals the expected monetary value of medium. Small is 8 minus P. Medium is 5 plus 9P. Go through all this, I find out that 3 equals 10P, P equals 0.3. At 0.3, if I have a 30% probability of strong demand, I am indifferent between small and medium. If the probability of strong demand is between 0 and 30%, we would prefer to invest in small. Once we get past this point, we prefer medium. We also need to find the indifference point between medium and large. So we'll do the same thing again. We'll come over here. Expected monetary value of medium will equal expected monetary value of large. Medium was 5 plus 9p. Large is minus 9 plus 29p. A little bit of algebra in here. We end up with 14 equals 20p. The probability is at 0.7. So this one is 0.7. If the probability of strong demand is between 30 and 70%, we prefer to invest in medium. From 70% to 100% probability of strong demand, we are going to invest in large. It gives us the highest expected monetary value. We now can, of course, build another model off of this. We can sit there and say, just like we did earlier, if 0 is less than or equal to the probability of strong demand is less than or equal to 30%, we would choose to invest in small. If the probability is between 30 and 70, we would choose to invest in medium. And if it's between 70 and 100% that we will have strong demand, we would prefer to go with the largest possibility, the largest outcome. We would go with large condos. Remember, your values for P must be between 0 and 1, 0% to 100%.